This is a video from the Exam 3 review in my linear algebra class. Let's take a look at problem 3. Find a matrix P that diagonalizes A, which is given by the matrix 1, 0, 6, negative 1. Compute P inverse AP. Now, lambda I minus A is equal to the matrix lambda minus 1, 0, negative 6, lambda plus 1. Set the determinant of lambda I minus A equal to 0, which says lambda minus 1 times lambda plus 1 equals 0. So lambda equals 1 or lambda equals negative 1. So those are my eigenvalues. Now, for lambda equal 1, right? So in other words, I'm going to come back here and replace lambda with 1 here and over here. And when I do that, I get the matrix 0, 0, negative 6, 2. I'm going to multiply that by the column vector A1, A2, and I'm going to set that equal to the column vector 0, 0. So what am I trying to do? I'm trying to find an eigenvector that corresponds to lambda equals 1. And so if you notice, negative 6A1 plus 2A2 equals 0. Solving for A2, I get A2 equals 3A1. So I'm going to let A sub 1 equal 1. And if I solve for A2, I get A2 equals 3. And so P1, which is the column vector 1, 3, is an eigenvector that corresponds to lambda equal 1. Okay. Now, for lambda equal negative 1, so I'm going to take the matrix negative 2, 0, negative 6, 0 times the column vector B1, B2 and set it equal to the column vector 0, 0. So B1 equals 0 and B2 is free. And so what I'm going to do is set B2 equal to 1. And so P2 is the column vector 0, 1. And remember, P2 is an eigenvector of A corresponding, right, to lambda equal negative 1. Now, notice we got an eigenvector of A, right? P1 is an eigenvector of A corresponding to lambda equal 1. And then we got P2 as an eigenvector of A corresponding to lambda equal negative 1. And so what I'm going to do is form the matrix P whose columns are those eigenvectors that I found. So notice how my first column of matrix P is 1, 3. My second column is 0, 1. Okay? So that's P. Now, P inverse is the matrix 1, 0, negative 3, 1. Okay, so now we want to calculate P inverse AP. And if we did it right, we should be getting the, along the main diagonal, we should get a diagonal matrix, first of all. And we're going to get the eigenvalues of A along the main diagonal. Now, when I calculated P inverse A, I got the matrix 1, 0, 3, negative 1. And then when I calculate P inverse AP, I get the matrix 1, 0, 0, negative 1, which is exactly what I wanted. And that's how you do problem number 3 on the Exam 3 review. Okay, thank you.